Okay, here it is, the last video of the school year. Unit 4, Lesson 17 is the second part of solving equations, systems of equations. Today we're going to take a look at the special cases. As usual, there's always some weird things that happen with numbers, alright, and systems are no different than anything else. So, remember our term system of equations, alright, is a solution to a system of equations is when the two lines meet at a certain point. And then you'll notice there's a question here, but what if they never cross? Or what if there only appears to be one line? Alright, there are some special cases, and that's what we're going to be looking at today. So, looking at the three types of solutions that you could possibly have. The first one is the thing that we've been looking at over the last few days, okay, and that is when you have two lines that meet at one point, the solution is that ordered pair where they meet. However, it's possible that the two lines never cross. Alright, there is going to be no solution. Okay, when they never cross, alright, that means those lines are parallel. Alright, you have two lines that never cross are parallel, and there is no solution. It's possible that you actually have the same line that you're graphing, and in which case you're going to have infinitely many solutions. Alright, so let's go ahead and take a look at the three examples we have here. Okay, you'll notice there's three more on the bottom as well. Let's go ahead and do the first one together. Alright, I have in the first problem my slope is 1 and my y-intercept is 0, negative 1. So I go to graph 0, negative 1, up 1 over 1, up 1 over 1, up 1 over 1. Again, the more points you put, the better off you'll be. Alright, and then we go ahead and place our graph on there. We should be pros at this. This is slope-intercept graphing. Okay, and there's our first line. Alright, so we go ahead and graph our second line. We have a slope which is 1 and a y-intercept at 0, 5. So I go 1, 2, 3, 4, 5. Up 1 over 1, up 1 over 1, up 1 over 1. Alright, and I go ahead and create this graph using my straight line. And what you see, once again, is what we would define as parallel lines, because these are two lines that are never going to touch. So if we're asked to solve the system, we would say that there is no solution to this. In other words, these lines are never going to touch. Alright, let's go ahead and skip. We're actually going to skip both B and C for right now. And we are going to go ahead and drop down to D. Alright, so when I take a look at D, my first one's in slope-intercept form, so that means my slope is 3 over 1, my y-intercept is 0, negative 6. So I put my dot down there, 1, 2, 3, 4, 5, 6. I go up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. That should be enough. Draw my line in. Alright, and I have a line going through my graph looking like that. Alright, now I look at my second equation, and I know my second equation is in standard form. Alright, and this is a review topic, graphing with intercepts. I'm going to have to go ahead and find my intercept. So I have, 6. My x equals 2. That's the point 2, 0. And I have to find my y-intercept. Divide by 2, I get y equals negative 6. And so I have 0, negative 6. So 2, 0. Let me do this in a different color. We'll do it in purple. 2, 0 is right there. 0, negative 6 is right there. And if I go to draw these lines in, guess what? It's the same line. Okay, here's an example where you graph two different equations but end up with the same thing. This is a graph that's going to have infinitely many solutions. What that means is, again, the solution to a system is the single point where two lines meet. Well, if a line is laying on top of a line, that means it's going to meet at every single point possible. It'd be impossible to name all the points. It would be like, saying here 2, 0, and then coming over here to 3, 3, and then whatever the next one is, and whatever the next one is, and having to list all those points plus all the fractions and decimals in between. It'd be impossible to do, so we say there's infinitely many solutions. All right. We're going to do one more example together, and I'm going to do example F. Okay. You'll notice that in this case, both of these equations are special cases in their own right, in that we wouldn't use one of our two methods to graph. Instead, we would go ahead and list our ordered pairs, all right, and create our graphs this way. So there you have it, one. And then the other one would be -9. So I could just boom, boom, boom. These are -9s now. All right, so I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And obviously what we're seeing here is going to be what we saw in the first example. These lines are going to end up being parallel. Oops. They will eventually be parallel once I fix that. There we go. Alright, so these lines are parallel because once again, if you look at them, they basically look like railroad tracks. They're never going to touch each other. Alright, and because of that, there is no solution. Alright, and there you have it, the last video of the year. There's 3 more problems on the paper that we'll do tomorrow in class. See you tomorrow.